As we commence this academic gathering, so let us seek a grace and guidance through an invocation. I cordially invite Mr. Ange to render the invocation.
स्वागतं शुभ स्वागतं अथ स्वागतं शुभ स्वागतं आनन्दमङ्गलमङ्गलं नितप्रियं भारत भारतं स्वागतं शुभ स्वागतं अथ स्वागतं शुभ स्वागतं नित्यनिरन्तरता नवता मानवता समता ममता सारथि साथ मनोरथ का जो अनिवार्य नहीं थमता संकल्प अविजित अभिमतम संकल्प अविजित अभिमतम आनंद मंगल मंगलम नितप्रियं भारत भारतं स्वागतं शुभ स्वागतं अथ स्वागतं शुभ स्वागतं कुसुमित नई कामनाएं सुरभित नई साधनाएं मैत्री मत क्रीड़ांगन में प्रसुदित नई कामनाएं शाश्वत सुविकसित अतिशुभम शाश्वत सुविकसित अतिशुभम आनंद मंगल मंगलम नितप्रियं भारत भारतं स्वागतं शुभ स्वागतं अथ स्वागतं शुभ स्वागतम्
I am delighted to invite Dr. P.S. Niranjan, Head Department of Civil, to address the gathering and formally welcome all the dignitaries to this international conference.
Good morning. Good morning, the one and all present here, and a warm welcome to everyone. Distinguished dignitaries, respected keynote speakers, eminent researchers, academicians, industry experts, delegates, and dear students. It gives me immense pleasure and honor to warmly welcome you all to the second International Conference on Science and Technology for the Sustainable Future, organized by the Department of Physics, Chemistry, Mathematics, Biotechnology, and Civil Engineering Department, in association with Acharya University, Uzbekistan. To brief about my institution for the benefit of the chief guest and well-wishers, this institution has been birthed during the year 2000 as an ACT approved and VTU affiliated college by our dynamic founder, Honorable Chairman, who is none other than B. Premath Reddy, and the young dynamic managing director, Mr. Krishna Basani. Today we have grown to an institution with a 12 UG programs and 2 PG programs and R&D centers in almost all the major departments. And I am very happy to inform you that our institution got accredited by NAC with A grade, and few programs in our institutions got accredited by National Board of Accreditation, New Delhi. Following the encouraging success of our first edition, this second conference stands as a reaffirmation of our collective commitment to advancing scientific knowledge, technological innovation, and sustainable development. This conference brings together a diverse and distinguished group of participants from academia, research organizations, industry, and policy-making bodies across the globe. It provides a unique forum to exchange ideas, present cutting-edge research, and engage the meaningful discussions that bridge science and technology with the principles of sustainability. Over the course of the conference, we will explore emerging trends, innovative solutions, and interdisciplinary approaches aimed at building a resilient and sustainable future. I am confident that the keynote address, technical sessions, and interactions will inspire new perspective, fosters collaborations, and contribute significantly to both academic research and practical applications. On behalf of the organizing committee, I extend my sincere gratitude to our esteemed honorable chief guest of today's function, keynote speaker, Professor Muhammad Mustafa, Department of Chemistry, IISER, Pune, who has accepted our invitation and come here in spite of his busy schedule. We feel honored by your presence among us, sir. We welcome you, sir. I request our principal, Dr. Marigoda, sir, to present a sampling to the chief guest. Please accept, sir. I also extend my sincere welcome to our beloved dynamic principal, Dr. C.K. Marigoda, Acharya Institute of Technology, whose support and contributions made this conference possible, who has been steering this institution on the path of growth through his dynamic leadership and transformed Acharya Institute of Technology into a modern institution, ranking among the top 5 institutions of the Karnataka, busy with growing academic research, sports, and extracurricular activities. We all are extremely heartily welcome you, sir. We feel honored by your presence among us. We welcome you, sir. I request our Professor Satish, head of the Department of Chemistry, to present a sampling. Please accept, sir. I also extend my sincere welcome to our Institute Dean, Research and Development, Professor Devasis Pradhan, to this conference. I request Professor Rajanna, Dean Student Affairs, to present a sampling. Please accept, sir. I also welcome in absentia Sri C.B. Bhushan sir, Executive Chairman of the Acharya Institute, for encouragement for this conference. I welcome all delegates, research scholars, academicians, industry persons to this conference. I also extend my welcome to all organizing committee members of the departments of all the departments, faculties and student coordinators, faculty members, technical staff members, and beloved students. I wish all delegates a productive, insightful, and enriching conference experience. May this deliberation lead to knowledge creation, innovation, and meaningful actions towards a sustainable future. Once again, I warmly welcome you all and declare the second International Conference on Science and Technology for Sustainable Future open. Thank you.
Thank you so much, sir. Let us illuminate this conference with the light of wisdom and innovation. I request our honored guest to grace the dais. I also request one of the participants to come forward and join the lighting ceremony.
To provide an overview of the program, I warmly welcome Dr. Shilpa Shivashankar, Head, Department of Biotechnology, to address the gathering.
Good morning, one and all. Respected dignitaries on the dais, esteemed speakers and delegates, distinguished researchers, academicians, my fellow colleagues, and faculty, and young innovative minds. Sustainability is no more an option, but it's our shared responsibility. In the history of human progress, science and technology have always been the driving force to have led to transformation. Today, however, we stand at a critical juncture where innovation is not only innovation is not only going to advance convenience and growth, but also ensures sustainability, equity, and responsibility. In this context, that the second International Conference on Science and Technology for Sustainable Future assumes immense relevance, where 5 departments have joined hands together to make this conference a success. 3 from basic sciences, physics, chemistry, and maths, 2 from engineering, biotechnology, and civil. This conference is not merely an academic gathering, but also the convergence of ideas, disciplines, and global perspectives aimed at addressing the most pressing challenges, may it be human health, or energy security, and environmental resilience. This program is carefully structured to encourage solution-oriented discussions, foster interdisciplinary collaborations, and translate research outcomes into real-world impacts. International Conference on Science and Technology for Sustainable Future provides vibrant platform where cutting-edge research meets industry standards, where policy perspective interacts with technological innovations, where experienced researchers engage to work with young researchers and students. Through the keynote address, technical sessions, and scholarly articles, this conference promotes not only a novel idea, but also the ideas that are ethically grounded, socially relevant, and environmentally sustainable. The need for such conference cannot be overrated due to the global challenges that has been arising, such as climate change, emerging health issues, resource depletion, and energy transitions that are complex and interconnected. No single discipline, institution, or nation can address this issue in isolation. These conferences like this play a vital role in breaking disciplinary silos, encouraging cross-border collaborations, accelerating the collective spirit of sustainable solutions. At EIT, sustainability is not embedded just in the research agenda, but also in our institutional ethos. As a reflection of a commitment to be a part of the ongoing sustainable solutions, Acharya Institute has established electric vehicle charging ports at the 4 cars at the parking lot, which is a new initiative that was recently initiated. And this is to promote green mobility and clean energy practices. This initiative symbolizes our belief in meaningful change begins with actionable steps, however small it may be. We strongly believe that the institutes of higher learning must lead by example and integrating sustainability into research, education, infrastructure, and community engagement. As a part of this, we have been doing multiple initiatives, but I want to quote one example wherein we have educated our underprivileged in and around our community by assembling a solar panel which could one day lit light when their home was dark. It's an emergency light that we kind of give an essence of. At EIT, I again want to repeat, at EIT, we do not just preach, but we practice. International Conference for Science and Technology International Conference on Science and Technology for Sustainable Future 2026 stands as a testament to our vision, empowering researchers and students alike to innovate responsibility and think beyond conventional boundaries. I am confident during these deliberations of the conference, we will ignite new ideas, inspire collaborative research, and strengthen global partnerships aimed at building sustainable and resilient future. Lastly, let us innovate not just for progress and growth, but to lay a strong foundation of a greener planet for tomorrow and continue to do so for the generations to come. Thank you.
Thank you so much for your words of wisdom, ma'am. Now, it's my privilege to invite Professor Devasis Pradhan, Dean R&D, to address the gathering and share his valuable insights. Welcome, sir.
So, namaste. Respected Principal Sir, keynote speaker, senior faculty members, fellow colleagues, and all our dear participants. Now, already Madam has spoken so many things about the conference. Niranjan Sir has already given us a welcome address to all of the participants. So, we have already welcomed. We are in the same dashboard. Now, this conference we have propelled in the last year, that is the first edition, and we have seen the changes. This year also there are good participants with a various diversified area. Basically, this conference were organized to collaborate, to enrich ourselves. It is a platform through which we can exchange our information, exchange our thought process in a better way towards innovation, toward research build-up, toward profiling, individual profiling, institutional profiling, institute interactions are there, institute industry interactions will be there. I will request all the participants do not lose the opportunity at a single moment also. If the option has been given to you, please present yourself, exchange your ideas, please defend the queries by the session chair or the participant if they have raised any query, please defend it positively, take the points in a positive manner, it will help you in a future also. And these sort of dashboards, the outcomes when we see, it should be in a right dashboard. It should be allowable us to replicate us in a global platform. So we have collaborated our this conference with very good publisher called Cambridge Publisher and Dr. Alison Duffy, who is the Chief Editorial Board of Cambridge Press. She has congratulated all the team member. She has given a heartfelt welcome to the whole institution that they are collaborating with us. And they have given the 3 series. I would like to tell there are 3 series she has agreed to give it to the conference because we are having 6 to 7 tracks and we are helping each and every faculty member, each and every participant to be available in a global dashboard. And she has extended her heartfelt thankful to the organizers, committee members. Each and every person is considered and we require the positive participants, positive outcomes should be there, replication should be there, institutional replication should be there, author replications is also there. Because these are the dashboard where we can enrich ourselves. And I would like to thank the whole committee member that they have taken a positive step and they have come forward with so much participants, online as well as offline participants are available. When I discussed with Satish sir, when I discussed with Deepashri madam, they told that there are the very good participants are available across India as well as across globe also we have some participants. So let us not lose any sort of session. If we are in the dashboard, let us collaborate, let us have some one-to-one discussion, and these are the platforms are created which help us to enrich ourselves, to enrich the institutional growth, institutional visions, and as well as the self-vision, self-goals, self-motivation should be there. So in this note, I will close, and I will thank the whole committee member who has taken a very good step to conduct this conference. And I would like to thank our management, principals, sir, whose directions, whose visions are very positive toward research, toward innovation. And what we do, the best thing is that we practice. Madam has told that we practice. Yes, definitely we practice. And this practice definitely help us to enrich ourselves. Thank you all.
Thank you, sir. It's a privilege to welcome our honorable academic leader and the guiding force of our institution, Dr. C.K. Marigoda, Principal, Acharya Institute of Technology, to deliver the presidential address. Welcome.
Very good morning. Good morning. You need not to worry in terms of a noise pollution. You are talking about sustainability. Very good morning. Okay. Instead of wishing good morning, I thought of wishing happy morning. Always there is a difference between good and happy. Good not necessarily an happy, but always an happy, it leads to a good. Okay, happy morning. Respected today's chief guest and keynote speaker, Dr. Mustafa sir, Professor Aiser Pune. Thank you, sir, for taking out your time and to take a commitment to participate in this conference and to deliver the keynote, the address. Thank you for your good gesture in visiting our campus. Give a big round of applause. If I look at the theme of the conference, the theme of the conference is Science and Technology for Sustainable Future. We can replace a word, it is not future, we can replace a word today and future. It is very important. Today itself, we need to focus towards the sustainability. If you look at the theme of the conference and if you look at the tracks of the conference, just I'm trying to map by using a chat GPT. You tell me out of sustainable development goal, totally as part of UN sustainable development goals, totally there are 17 goals of SDG. Out of 17 goals of an SDG, if I do the mapping, immediately the ChatGPT has done the mapping by fetching the title of the conference, by fetching the tracks of the conference, it has done the mapping. Out of 17 sustainable development goals of UN, it is done the mapping for 15 sustainable development goals. That means one conference is addressing 15 goals of SDG, except two goals. One of the goal is no poverty, and one more goal is is with respect to gender equity. Except these two SDG goals, this conference is addressing to 15 sustainable development goals of SDG. That itself, it is very important. The designing this conference with the title and the track, I would like to really appreciate the effort of organizing the committee. Total 5 departments collaboratively, they are hosting this conference. 3 basic science, the department, and 2 the engineering department, biotechnology, as well as the civil. 3 basic science department, chemistry, physics, and mathematics. Let us give a big round of applause to organizing committee. Sustainability, in my sense, I'll tell you, the technology will enhance, and at the same time, it is very important not just only to do the innovation in technological advancement. It is very important we need to address the sustainability. Today we are talking about generative AI. You take ChatGPT or you take Gemini or you take any tool. Most of us, each one of us, we are using every day in, day out, our work as well as for the studies, we will use a generative AI. And the amount of the prompt, what we are going to give to a generative AI, it has to take your prompt as a command, and the server has to run with the knowledge database, we call it as a super knowledge database, and from that it has to retrieve and it has to give the result. For that, the generative AIs, the servers, the GPUs, are running at a speed in which it is generating a carbon emission. And nobody is talking about with respect to the technology advancement is one level, coming out with a new functionality, introducing the new generative AI tools for our daily routine and to reduce and to increase the productivity. And at the same time, we have a sense of responsibility to address the carbon emission. If we don't address carbon emission, definitely I'll tell you, it will lead to a society, it is not sustainable. It leads to a society wherein it will create a lot of hazards and it is very difficult. That is where my sincere request for all the researchers, one end science and technology has to be advanced in terms of an innovation, and at the same time, we need to have a sense of responsibility, as we call it as an engineers or in the vertical of a science and technology. As a researcher, it is very important, whatever the advancement you do, and at the same time, it should not affect our society, it should not affect our environment. It is our commitment. In that particular context, 2 days of a deliberation, don't look at only in terms of an innovation towards the science and technology, also you address in terms of a sustainability. And one more, we are talking about smart cities. And I really don't know, everywhere we are deploying IoT as a sensors. How many millions of sensors which we are deploying as part of an IoT application in making everything as a smart manufacturing, smart health, smart city, smart education. Everywhere we are deploying a sensors. How many thousand, millions of sensors have been deployed? But what is the life of the sensor? And once after the sensor is die, then who is going to take care of that particular the material? It is very important. We need to address all those issues. There are lot of open opportunities are there for you to carry out the research in the vertical of a sustainability. I wish 2 days of a deliberations will lead to the very good amount of the outcome as part of this the conference. And I wish each one of you, I would like to thank all the researchers. I got to know from the organizing committee. Out of curiosity, I wanted to know how many total number of registrations. Total number of registrations, they have received 147 registrations. Let us give a big round of applause. And we at Acharya Institute of Technology, we are not focusing just towards the volume of the publications. Always, we are very keen in terms of the quality of the publications. 147 really a very good quality publications what they have shortlisted. And if I see the diversity in terms of the participation, across most of the states across the country, the participation, not just restricted only within the country, also there is a participation from international participation outside India. And we have also been collaborated with Acharya University, Uzbekistan. For your information, Acharya has established an IT university. It is the initiative of the President of Uzbekistan, wherein the President of Uzbekistan has given the responsibility to Acharya to run an IT park for the Bukhara region of Uzbekistan. And we are instrumental in that. And as an institution, we are not just supporting our students, we are not supporting only the development of a country. As a responsible organization, we wanted to support our neighboring country. That is where we have taken a commitment, not just only to make India proud, and also to support our neighboring country for them to get the growth. Where in 1990s, Uzbekistan got the independence from USSR, and after that now they are focusing towards an IT to make the country progressive, and Acharya is also instrumental in supporting the growth of Uzbekistan. What I mean to say is, Acharya as an institution, we are not just committed only for education, only for graduating our students. We are also committed in terms of innovation and social responsibility. And if you look at our campus, we have a campus with a dimension of 120 acres, out of which 120 acres, we have not done the complete built-up area for 120 acres. You know what is the land value in Bangalore. But still, our honorable founder chairman, he has a vision that out of 120 acres, we have utilized only 35 to 40% of the land area as a built-up area. Remaining 60% of the area, we have maintained green. That is what our commitment as an institution, and that is what we expect from our graduates. Let us work together to make this particular country proud, and the vision of 2047 Vikasit Bharat, where in 2047 we are supposed to declare India as a developed country. No more it is a developing country. By 2047, remaining years left out, 2026, 21 years left out. We all as a researchers, we need to work towards the development of this and achieving Vikasit Bharat, a developed country, 2047. Thank you.
Thank you so much, sir, for your inspiring words. Now, I cordially invite Dr. Satish K., our distinguished Head Department of Chemistry and First Year Coordinator, to introduce a keynote speaker to this esteemed gathering. A warm welcome, sir.
So, very good morning. So, it is our great honor and privilege to introduce our esteemed keynote speaker, Dr. Muhammad Mustafa, a distinguished Indian electrochemist and accomplished academic researcher, internationally recognized for his pioneering contributions to electrochemistry. energy storage and conversion, and molecular electrocatalysis. Dr. Mustafa is currently a professor in the Department of Chemistry at the Indian Institute of Science, Education and Research, so popularly known as ISER, Pune. You obtained his PhD from the Indian Institute of Science, Bangalore, where his doctoral research focused on fundamental mechanisms and interactions in fuel cell electrocatalysis. Following this, he pursued postdoctoral research at the University of St Andrews, Scotland, UK, with a strong emphasis on battery materials and electrochemically stability. Dr. Mustafa joined ISER Pune in 2014 and has steadily progressed from assistant professor to professor. Over the years, he has successfully secured a research funding worth 6.5 crore from prestigious agencies including DST ACRB, DST TMD, and the Nano Mission, reflecting both the quality and national importance of his research. An inspiring mentor, Dr. Mustafa has successfully guided 11 PhD scholars, and currently 12 research scholars are pursuing their doctoral studies under his supervision. His scholarly output is remarkable, with over 110 research publications in reputed national and international journals and 5 patents to his credit. His research interests span interfacial electrochemistry, focusing on electrode-electrolyte interactions, energy storage and conversion devices, including batteries and fuel cells, molecular electrocatalysis for sustainable electrochemical reactions, and electrochemical sensors and water splitting technologies. At ISER Pune, Dr. Mustafa leads the Electrified Interface Group, a vibrant research team dedicated to cutting-edge electrochemical science and innovation. He also maintains strong industry collaborations with organizations such as Shell, Green Energy Tech, Nissan Motors, BITS Biosite Foundation Goa, among others, bridging fundamental research with real-world applications. And yesterday we had a formal discussion with Dr. Mustafa. So one of our student, just so by looking at our keynote speaker, he was asking, "Sir, you are saying he is our keynote speaker for the conference, but he looks to be very young." But dear participants, so I would like to mention here, and our Honorable Prime Minister Sri Narendra Modi ji and Nitin Gadkari, so both of them visited his lab, and where the world is talking about sustainability, and then so they have developed his, and his team has developed the, by using the cow urine, the battery system to visit. So the Narendra Modi ji and Nitin Gadkari, both of them visited his lab. So we need to give him a big round of applause. And also, so I'm happy and proud to say that, so we as Acharya Institute of Technology, so we have a very strong collaboration with our keynote speaker and one of our faculty, Dr. Harish MNK. So so he's working closely with Dr. Mustafa and team. So this collaboration has resulted in significant research breakthroughs and several high-impact publications, so further centering the academic ties between our institution. Ladies and gentlemen, so it is indeed a privilege to have such an eminent scientist and visionary researcher with us today. So please join me in warmly welcoming again our keynote speaker, Dr. Mustafa. Thank you, sir.
Thank you, sir. I now have the honor of inviting our esteemed keynote speaker, Dr. Muhammad Mustafa, Professor ISER, Pune, to enlighten us with his valuable insights, words of wisdom. Welcome, sir.
So please. Sorry. Okay, sorry for the inconvenience, and we'll go ahead with the felicitation of our today's keynote speaker, and we will formally closing later on, and then we will start break for a tea, and then we'll go with the session. Yeah.
I would like to invite all the dignitaries to facilitate our esteemed chief guest. Sir, please. Felicitations, sir. Sir. Conveners, please join with sir, ma'am. Sir Devasi, sir, please join with. Thank you, sir. Thank you very much. It is our privilege to honor you. We are very happy to have with you, sir. I now have the honor of inviting our esteemed keynote speaker, Dr. Muhammad Mustafa, Professor ISA, Pune, to enlighten us with his valuable insights and words of wisdom. Welcome, sir.
Yeah, good morning, everyone, and so I'm very honored to be here in Acharya Institute of Technology for this wonderful gathering of scientific minds. And I'm really thankful to the organizers, especially Professor Satish, for inviting me for this scientific gathering. I have been collaborating with the faculty of this Acharya Institute since the day I joined ISER Pune as an assistant professor in 2014. Since then, I know the quality of the faculty in this place. So you have excellent faculty of international caliber, which was clear to me during my interaction with the scientific faculty yesterday at this institute. I request the authorities of this institution to utilize these strengths very, very effectively. Once again, very thankful to everyone for inviting me for this wonderful gathering, and thank you very much. Jai Hind.
Thank you so much, sir. As we formally come an end of our formal inaugural session, I kindly request Dr. Kavishri D., Head Department of Physics, to offer the vote of thanks on behalf of the organizing committee. Warm welcome, ma'am.
Honorable Principal, esteemed coordinators, respected heads of the departments, distinguished guests, faculty members, delegates, participants, and dear students. A very happy morning. It is with a great pleasure and gratitude that I stand before you to extend a heartfelt vote of thanks on the occasion of the successful inauguration of Second International Conference on Science and Technology for Sustainable Future 2026. First and foremost, I extend my heartfelt gratitude to Shri B. Premnath Reddy, Founder Chairman, Srimati Shalini Reddy, Executive Director, and Shri Krishnapasani Reddy, Managing Director, Acharya Institutes, for their visionary leadership, constant encouragement, and unwavering support. In their absentia, I would like to extend a thanks. We are deeply grateful to Shri C.B.M. Bhushan, Executive Chairman, Acharya Institutes, for his invaluable guidance, inspiration, and support. In his absentia, we thank C.B.M. Bhushan, sir. My sincere thanks to our Honorable Principal, Dr. C.K. Marigoda, for his continuous motivation, leadership, and guidance in organizing this prestigious event. Thank you, sir. My sincere thanks to Dr. Mohammad Mustafa, Professor, Department of Chemistry, IISCR, for accepting our invitation. Thank you, sir. I also extend my heartfelt thanks to Professor Devasis Pradhan, Dean R&D, for his support and guidance. Thank you, sir. My sincere thanks to Dr. Rajshekhar Patil, Head QA, for initiation and guidance for conducting this conference in his absentia. I extend my sincere thanks to Dr. Satish K, Head Department of Chemistry, Dr. T. Ramireddy, Head Department of Mathematics, Dr. Niranjan PS, Head Department of Civil Engineering, Dr. Shilpa Shivshankar, HOD Department of Biotechnology, for their constant support in effort in making this conference for this happen. I extend my appreciation and gratitude to the organizing committee, coordinators, session chairs, faculty members, reviewers, and volunteers whose dedication, teamwork, and tireless efforts ensured the smooth conduct of this inaugural session. I also thank all the participants, researchers, academicians, and students for your enthusiastic participation and for making this conference a vibrant platform for knowledge sharing and collaboration. Last but not least, I acknowledge the effort of the technical team, support staff, and everyone who worked behind the scenes to make this event a grand success. With this, I once again thank each and every individual who contributed directly or indirectly to the successful inauguration of this international conference. Thank you all. Have a wonderful conference ahead.
Thank you, ma'am. I request everyone to rise for the national anthem. Thank you all. Please be seated. After the tea break, we will start the keynote speaker session. Please kindly join for the tea. 10 minutes time, please. Group photo, please. Participants and all faculty members, please kindly join. One group photo, please, outside.
Okay, once again, I would like to welcome prestigious organizations for the second international conference on science. And so, and honored to welcome once again our today's keynote speaker, Dr. Muhammad Mustafa. Sir, I would like to welcome you on behalf of entire Acharya family, and the session is over to you, sir. Please welcome.
Yeah, thank you, Professor Satish, for your kind introduction. And the title of my presentation is Water Formation Energy Driven Electrochemical Process Modulation. And yes, let me select a pointer. Yes, so let me just define what is this water formation energy at the outset. Okay, water formation energy means it is the energy of the acid-base recombination reaction, that is H plus OH minus combining to form water. You must have done in your +2 level this kind of experiment where you have mixed acid and alkali in a beaker, and you must have observed that the beaker is becoming very warm. Okay, and my question is it possible to interconvert that heat as electrical driving force? That is a question. Okay, and there are two reasons why capturing that energy or heat as electrical driving force is important. The first reason is its industrial implication. That is majorly because the global annual acidic waste is almost 100 million tons of sulfuric acid globally if you take. And if you see, and before discharging them to water bodies, they undergo a neutralization reaction, the same H plus OH minus going to water formation reaction, and tremendous amount of heat or energy is wasted. Okay, and so if you do a back calculation, the amount of energy wasted corresponds to almost 44 terawatt hour of electrical driving force, which is actually tremendous amount of energy. So there is a point in capturing that energy as electrical driving force. That is the first point. And the second point is its fundamentally exciting nature, that is majorly because of its positive entropy change. People working in the domain of chemistry must be knowing about the entropy change, enthalpy change, all those parameters. And this reaction pathway of H plus OH minus recombination has got a positive entropy change, and that leads to a thermodynamic efficiency greater than 1 or specifically 1.43, which means more than 100% of efficiency. How is that possible? So that is possible only when the reaction proceeds in the device. It is able to capture the energy from the surroundings also as electrical driving force. Only then the efficiency can be greater than 1 or close to 1.43. So for this reaction pathway, the efficiency is significantly higher than 1, majorly because of the fact that this reaction pathway is able to capture the energy from the surroundings also as electrical driving force. And that is why when I raise the surrounding temperature, you can see this is surrounding temperature. When I raise the surrounding temperature, the voltage of the system is increasing, signaling that heat to voltage interconversion. And if you compare this reaction pathway with the conventional hydrogen-oxygen reaction pathway, you can see the entropy change is negative, the efficiency is lower than 1, and that leads to the exactly opposite behavior, where you can see when you raise the surrounding temperature, the voltage is decreasing, which means this reaction pathway does not have that capability to interconvert the surrounding temperature to electrical driving force, whereas the acid-base recombination reaction pathway has that capability, and that makes this reaction pathway very unique and very interesting. Of course, the reaction pathway is very interesting, exciting, industrially very, very important, but there is a challenge, and the challenge is already there in the reaction. H plus OH minus acid alkali, the combination leading to the formation of water. If you look at the species on the left hand side, H plus OH minus, and the right hand side, that is water. There is no change in oxidation state. For example, the oxidation state of H plus on the left hand side is +1, and the oxidation state of H plus on the right hand side is also +1, which means there is no change in oxidation state when the species proceed from left hand side to right hand side. Similarly, if you take the hydroxyl ions OH minus species, the oxidation state is -1, and on the left hand, and on the right hand side, again, in the case of water, the oxidation state of OH minus is again -1. So clearly you can see that when the species move from left hand side to right hand side, there is no change in oxidation state of any of the species, which means we are actually looking at a non-redox reaction. In electrochemistry, if you reaction has some amount of energy. If you want to capture that energy as electrical driving force, you must have a redox reaction. Only for a redox reaction, you can capture that energy as electrical driving force. And let me illustrate that fact with the conventional, with the classical Daniell cell. It's a +2 level science. This is a Daniell cell. Everybody knows about a Daniell cell. It has a zinc dipped in zinc sulfate and copper dipped in copper sulfate solution, and the total cell reaction is given here. You can see that. And if you look at what happens on the left hand side, this is what is happening on the left hand side. Zinc undergoes oxidation to zinc 2+. You can clearly see a visible change in oxidation state from 0 to +2. And that process should liberate 2 electrons. And those 2 electrons, when they move through the external circuit, they will provide you electricity. And the moment those electrons reaches the right hand side copper half cell, what will happen? Again, you can see copper 2+ undergoes reduction to metallic copper. Again, you can see a change in oxidation state from +2 to 0. So this change in oxidation state is very, very essential for the electrons to move across the external circuit and provide you electricity. If the reaction happens to be non-redox, the electrons cannot flow through the external circuit and provide you electricity. This says that if you want to capture a reaction energy as electrical driving force, you must have a redox reaction, and that is unfortunately not the case in the case of this H plus OH minus going to water formation reaction, because that reaction happens to be a non-redox reaction. And we have recently, so this is actually a challenge, even though the reaction is very unique and very, industrially very, very important. This is a challenge, and we have overcome this challenge by utilizing what is called hydrogen redox. This is majorly because we understood that this hydrogen redox usually happens through this reaction sequence, H plus going to water, +2 electrons, which means the reaction involves clearly protons, which means any property of the reaction should be dependent upon the concentration of protons, because the reaction depends upon the amount of protons, which means any property of the reaction has to be dependent upon the pH of the medium. That is why you can see the current voltage curve for the same reaction, for the same hydrogen redox, is shifting negatively along the voltage axis. J means current, E means voltage. You can see for the same reaction, when I make the pH more alkaline, pH 14 is alkaline, you can see the current voltage curve is shifting negatively along the voltage axis. And that tells that for the same hydrogen redox, the electrode potential is negative in alkaline pH, which means pH 14. And for the same hydrogen redox in acidic pH, pH 0, the electrode potential is relatively more positive compared to alkaline. Is here in electrochemistry, anything negative in electrochemistry has a tendency to undergo oxidation, and anything positive in electrochemistry has a tendency to undergo reduction. And this understanding offers opportunities for harvesting this water formation reaction energy as electrical driving force in a decoupled acid-alkali configuration as shown here. Here you can see I have decoupled acid and alkali in two compartments, and if I perform hydrogen redox in both the half cells, you can see in the alkaline compartment from our previous discussion, if I perform hydrogen redox in the alkaline compartment, it has to be negative, because you can see it is happening at a negative potential. And the acidic half cell has to be positive if I perform the same hydrogen redox. And we know that negative has a tendency to undergo oxidation. Oxidation of what? Oxidation of hydrogen through this reaction sequence. And this process should liberate electrons. Through the external circuit, they will provide you electricity, and the moment those electrons reaches the right-hand side acidic half cell, there has to be a reduction. Reduction of what? Reduction of protons, because it's a positive half cell. There has to be reduction. Reduction of what? Reduction of protons through this reaction sequence. So if you look at it very carefully, what is very important here is hydrogen is consumed in the alkaline compartment, hydrogen is evolved in the acidic compartment, then which means there is no net consumption of hydrogen. Then what is providing you electricity? The difference between the two reaction, that is nothing but the acid-base recombination reaction. So this way, by performing hydrogen redox, we are able to arrive at the same reaction, H plus OH minus going to water, and in this way we are able to interconvert that water formation energy or heat as electrical driving force. And we have done a series of measurements. These are all not important, and what is very important is this data of electrochemical mass spectrometry. And these are the signals for hydrogen. And you can see in the alkaline compartment, when I draw current from the device, the pressure of hydrogen decreases, suggesting hydrogen is consumed. Commensurately, in the acidic half cell, you can see when I draw electricity from the device, the pressure of hydrogen increases in the acidic compartment, suggesting hydrogen is evolved. This says that there is no net consumption of hydrogen. And then what should be propelling the device? The acid-base recombination. In order to prove that it is the acid-base recombination that is propelling the device, or that is delivering you the current, we have drawn a constant current from the device till the electromotive force drops to 0. And commensurately, we have measured the pH in both the half cell. And you can see the pH in both the half cell has a tendency to converge towards a neutral value of 7. And when I don't draw, when I do not draw any current from the device, you can see the changes in pH in both the compartments are negligible, suggesting that this convergence towards a neutral value of 7 is due to this reaction that is happening electrochemically and not chemically. So this actually proves that when I draw electricity from the device, there is a pH change, which means this reaction must be propelling the device. Otherwise, there should not be a pH change. So I have a video demonstration here. So what is very, very important here is there is no net consumption of hydrogen. I hope it will work. Yes, it will work. So what is very important here is there is no net consumption of hydrogen. Whatever the hydrogen I am using it for powering this load has to be evolved in the acidic compartment, and that is eventually collected in this hydrogen storage tank. So you will see some bubbles when the load is running, when the load is getting powered. And if that is actually hydrogen, I can pump that hydrogen to a separate hydrogen oxygen fuel cell that is kept here for additional electricity generation. That is the whole idea about the two videos. So the first video will show that when I power a load, okay, whatever the hydrogen that is consumed will be evolved in the hydrogen storage tank. You can see some kind of bubbling, which means whatever is supplied or consumed is actually evolved in the hydrogen storage tank. If that is pure hydrogen, I can pump that hydrogen to a H2O2 fuel cell that is kept on this left side. You can see that for additional electricity generation. And that is what is the second video. So you will be able to see that actually works, which means whatever the hydrogen that is consumed is actually evolved in the cathodic compartment. So there is a closed hydrogen loop. Whatever the hydrogen consumed, that is actually evolved and leading to a closed loop of hydrogen. And okay, so So this kind of water formation energy through the acid-base recombination provides lot of opportunities and possibilities, and one such opportunity is the removal of salt from saline water. That is the construction of a water desalinator. See, removing salt from saline water is very, very important for producing water for irrigation purposes and drinking purposes, because we can't use the seawater directly for irrigation purpose or drinking purposes. So we have to remove the salt, and the technology for removing the salt is called desalination. And using this approach of acid-base recombination, we can actually remove salt from saline water during electricity production, and to make that possible, we have actually made a 3-compartment cell as shown here, and the middle compartment house the water for desalination. And the working principle is quite straightforward. In the alkaline top compartment, this is the reaction that is going on, that is the oxidation of hydrogen. And you can see, if you look at that reaction scheme, that actually involves the consumption of hydroxyl species or negatively charged species, which means during electricity production, there is a kind of charge imbalance in the top alkaline compartment with respect to negatively charged species. And to mitigate that charge imbalance, Cl- from the middle saline compartment should migrate through the anion exchange membrane, AEM, to the top alkaline compartment. And commensurately, what is happening in the bottom half cell, that is the evolution of hydrogen, which involves the consumption of the positively charged protons. Again, you can see there is a charge imbalance with respect to positively charged species in the bottom acidic compartment. So to mitigate that charge imbalance, sodium ions, which is another positively charged species, should migrate through the cation exchange membrane, CEM, to the bottom acidic compartment. So you can see the net result of electricity production is a net desalination that is happening in the middle saline compartment. And everything is controlled by the supply of hydrogen. If there is no hydrogen, there is no desalination, because these reactions will not proceed. So you can see that when there is no hydrogen, you see that the amount of the extent of NaCl removal is very, very negligible. And when there is hydrogen, you can see there is a drastic decrease in the presence of, in the amount of sodium chloride in the middle. And also we measured the correspondence between the charge passed or the current we obtained, NaCl removed, and H plus OH minus consumed. And you can see there is a very nice one-to-one correspondence between all these parameters, suggesting that everything is driven by H plus OH minus consumption, and that H plus OH minus consumption drives NaCl removal during electricity production. And we have measured the energy efficiency of the process, and what is very important is this can even actually remove most of the salt from real seawater. And the second possibility, based on the same concept of water formation energy or H plus OH minus recombination, is the design of an alcohol reforming fuel cell. And this is again the fundamental equation concerning the acid-base recombination reaction. The downward arrow here shows that hydrogen is consumed. The upward arrow shows that hydrogen is evolved. Okay, and if I replace this hydrogen, for example, by a hydrogen storage molecule like alcohol, for example, methanol, which contains 2 molecules of hydrogen. Every molecule of alcohol, methanol, contains 2 molecules of hydrogen. It is CH3OH. The reaction will be transformed into something like this. If you look at this reaction, on the right-hand side, you have hydrogen, left-hand side, you have methanol. Or I would say, I can actually produce hydrogen from methanol during electricity production. Or I have designed an alcohol reforming fuel cell, because the production of hydrogen from methanol is often called as alcohol reforming process. So which I am doing it during electricity production, and this reaction pathway is very different from the rest of the reaction pathway with respect to alcohol fuel cell because of this additional component of hydrogen evolution. And remember one thing, that hydrogen production from alcohol often requires very high temperature and pressure, and here we are able to do this at room temperature and pressure during electricity production with the aid of this acid-base recombination energy. We could reform a range of alcohol, methanol, ethanol, short chain alcohol, long chain, and even glucose we could convert to very pure hydrogen by utilizing this approach. And this video demonstrates what is the meaning of an alcohol reforming fuel cell. So you can see here, this is the alcohol reforming fuel cell. The power of this is given to this table lamp. During that process, there must be the production of hydrogen, and that hydrogen is collected in the hydrogen storage tank. And that hydrogen can be eventually pumped into a H2. You can see there is a lot of bubbling, which tells that hydrogen is produced from alcohols, and those hydrogen will be eventually pumped into this H2O2 fuel cell. If that is pure hydrogen, it should be able to power this H2O2 fuel cell that is kept here. And everything happens at room temperature and pressure. And you can see that very clearly. It is able to actually drive two devices simultaneously. It can actually extract the power from H plus OH minus recombination, and in return it gives hydrogen, and that hydrogen is eventually used up in H2O2 fuel cell. So everything is powered by the first device. This device is actually supplying everything. And the third possibility, and for this audience I'll wind up here, the third possibility we have explored with the same concept of acid-base recombination is the possibility of constructing a hydrogen fuel purifier. You can see that this is again the fundamental equation concerning the acid-base recombination reaction, and hydrogen is consumed in the alkaline compartment and hydrogen is evolved in the acidic compartment according to our hypothesis. Okay? And there is actually a one-to-one correspondence between hydrogen consumption and hydrogen evolution. If there is no hydrogen, the device will not work. If you supply, for example, 10 molecules of hydrogen, there has to be 10 molecules of hydrogen evolution in the acidic compartment. So there has to be a one-to-one correspondence between hydrogen consumption and hydrogen evolution. That is very, very important for this device. Without hydrogen, the device should not function. And this understanding actually offers opportunities for what is called hydrogen fuel purification. For example, if I replace this hydrogen by an impure stream of hydrogen, say H2 plus X, where X is the impurity, the reaction will be transformed into something like this. This is majorly because in the impure stream of hydrogen, hydrogen is the electroactive segment, therefore only that hydrogen undergoes oxidation. And corresponding to that degree of oxidation, there has to be hydrogen evolution in the acidic compartment, and that has to be pure, which means I actually purified an impure stream of hydrogen to a very pure stream of hydrogen. And hydrogen fuel purification is very, very important industrially, because most of the industrially produced hydrogen contains carbonaceous and non-carbonaceous impurities, and you must remove them before feeding the hydrogen to a hydrogen oxygen fuel cell. So here you can see that this device can actually purify hydrogen during electricity production, that too at room temperature and pressure. The state-of-the-art methods for hydrogen fuel purification, they all require extreme temperatures and pressures as shown in this table. And here we can do this process at room temperature and pressure, that too during electricity production. And by utilizing this approach, I could purify hydrogen from various types of impurities, binary mixtures, including carbon monoxide and hydrogen sulfide, which are catalyst poisoning impurities. And we also could actually purify hydrogen from a complex mixture of impurities like this. You can see in the alkaline compartment, you have all the 4 components of the gas mixtures. You can see everything. Whereas in the acidic compartment, you can see predominantly the signals of only hydrogen, which means hydrogen is purified during electricity production. Energy efficiency also we measured. That is not very important for this audience. And this video finally will demonstrate what is hydrogen fuel purification during electricity production. You can see this is the device made by my students, and this device is actually based on H plus OH minus recombination, and it is actually propelled by an impure stream of hydrogen. And during that process, very pure hydrogen has to be produced, and that will be collected in this hydrogen storage tank, and which will be eventually pumped into an H2O2 fuel cell. If it is not a pure hydrogen, it cannot power this H2O2 fuel cell. That's the whole video about, and you can see now this video will show various components of the device. And during this process, so now I'm going to start bubbling of impure hydrogen stream into this device. It's a stacked device made by my students, and I can provide the power of that device to that particular load. It's again sketched by my students. And during this process, according to my argument, there has to be hydrogen fuel purification, and that purified hydrogen will be collected in this hydrogen storage tank that will be shown in a short while. So now you will see a lot of bubbling when I open that knob. So if that is pure hydrogen, then you should be able to pump that hydrogen directly to a hydrogen oxygen fuel cell. If it is not a pure hydrogen, H2O2 fuel cell cannot be powered. You can see bubbling now, which means that whatever the hydrogen that is supplied to the first device, that is purified and collected here. And if that is pure hydrogen, that will eventually should be able to power this H2O2 fuel cell that is kept here, which means it's happening, which means it's purify an impure stream of hydrogen to a very pure stream of hydrogen. Yes, so I don't want to go into this particular topic. Let me go to the conclusion. So what I'm trying to tell you is that this water formation reaction provides various possibilities and opportunities. It's a kind of an untapped thermodynamic reservoir, and it provides fresh opportunities and possibilities when you re-examine it from an electrochemical perspective. I have shown you the possibilities of salt removal from saline water. I have shown you the possibility of alcohol reforming fuel cell. I have also shown you the opportunity of hydrogen fuel purification. And there are possibilities existing for electro-organic synthesis, electrochemical sensors, supercapacitors, photoelectrochemistry, etc., based on the simple concept of H plus OH minus going to water, a classical +2 level reaction. And everything is summarized in this accounts of chemical research. And finally, I would like to show the translational capability of this concept of H plus OH minus going to water. We have designed an electrochemical stove based on this approach of water-based, the acid-base recombination. So this device is based on H plus OH minus recombination. The power of that device is given to this table lamp. And during that process, the hydrogen that is evolved will be pumped into a stove for various purposes, maybe cooking purpose. You can see that. That is possible. So the power of that device now based on H plus OH minus is given to this particular table fan, and you can see that it's even able to power a commercial electrical appliances. And during that process, that hydrogen that is evolved, which is collected in the hydrogen storage tank, and which we will be pumping into a stove, and you can actually power use it for various other purposes. You can see that it is possible to make an electrochemical stove, and this process is being scaled up. And thank you very much. And these are my collaborators, and I have very strong collaboration with the Acharya Institute since the day I joined in ISER Pune. And thank you very much. If you have any questions, I'll be happy to take it up. So we have used the platinum-based electrocatalyst here to begin with in the initial part of the work, because almost 5 theses came out of this particular acid-base recombination. So the first student has used platinum-based systems, and from the second students onward, we have replaced those with non-precious system like metal chalcogenides and various transition metal combinations we have exploited.
because I see that it's just an acid-base neutralization stuff. So can I use just a graphite electrode?
It may not work according to me. Graphite electrodes you can use if you want to make a supercapacitor based on the same approach, because this approach can expand the voltage window from 1.23 to 2 volt. So graphite electrodes can be used there, not for the purification or desalination or the alcohol reformation. There you cannot employ it because graphite is non-electrocatalytic. So you may have to have some kind of catalyst on the graphite electrodes to make it working.
I see that you have done some alcohol reformation as well as glucose also. So my question is, so can we use the concept to purify the pollutants that are there in the water? For example, alcohol has been reformed in the anodic compartment, right? So in the same time, glucose also has been reformed. So whatever the contaminants, the domestic sewage that is there, so it contains some organic contaminants. So what are the organic contaminants that have a capability to undergo oxidation? So can I use them to remove the pollutants and at the same time to produce the energy and fuel also, that is the hydrogen?
Okay, so I have to be very honest here because you are talking about an industrial level pollution.
Yeah.
Okay, so since I have not done those experiments with my own group, I cannot comment on it authentically. But if there are groups which can be oxidized, which I think the possibility exists in contaminated water, then there is a possibility that you can harvest that electricity and you can purify to some extent. But we also need to worry about the electrocatalyst poisoning by other contaminants present in that water system, which needs to be relooked at. So theoretically speaking, yes, it is possible. Practically speaking, it may not be so viable.
One more thing is, how about the separator that you have used? How is the stability, or can we, I think it's Nafion, right?
We have used Nafion membranes and for the most of the work. And for the desalination part, we need a bipolar membrane with cation as well as anion conducting regions. For that, we have used FEMA submembranes. They are reasonably stable under those pH conditions. But if you increase the pH to extreme levels beyond 0 and 14, then it may not really be stable.
Is there any possibility of using solid state membranes?
Solid state membranes, see the bipolar, solid state membranes, I really don't think so. But you can actually make a bipolar membrane. For example, the AEM and CEM, you can sandwich together and make one membrane. And then you don't have to supply H plus or H minus separately. It will itself will supply by splitting the water molecule. Solid state membranes, I'm not sure. I can't think of anything.
Any other questions?
Yeah, so it has various it has various possibilities. So people, it's an electrolyte basically. So it has got a lot of ions. It contains a lot of urea, okay, and the urea can function as a fuel source. That is what basically it is. So what we did was we used that urine as an electrolyte, and we can able to generate electricity as well as hydrogen fuel. And for that, what is very important is the 2 electrode configuration becomes very, very important. And with all electrodes, it cannot work. So we have my student, in fact, a student from Karnataka only, he found that. He actually found a kind of unique electrode configuration which can sustain the electron flow along with hydrogen fuel production. And he also found that you can apply a voltage and convert that urea into hydrogen using electricity. There are 2 possibilities. So when you apply electricity to the urine containing electrolyte, you can use various types of electrodes. But if you want to generate electricity along with hydrogen, then you need to have very specific set of electrodes. And if you ask me what are those electrodes, I cannot reveal those. That's what it is.
Yeah, during Dr. Sadesh was introducing you, he told about the visit by our Honorable Transport Minister, Mr. Nitin Gadkari, and he's building highways, as we know, and he himself, I think, he recently got a car which is like hydrogen fuel, which runs on hydrogen as a fuel. So anything on those lines, the visit was to collaborate, and I just wanted to understand anything on that you are working.
No, I didn't understand the last part. Can you repeat again?
Any collaboration with the government Ministry of Transport for using hydrogen as a fuel for
yes,
fueling vehicles? Yeah.
So this is again extrapolation of your question. So see, when Prime Minister Modi ji visited ISER Pune in 2019 December, I got the opportunity to present the concept of urine, as an electrolyte for batteries and hydrogen production in front of him. And he later, asked Nitin Gadkari ji to visit my lab and inspect and what are the possibilities. So he came up with a very big scientific team to see whether it is actually, whether it has translational potential. And along with my students, again, we had shown a commercial viability of that particular setup. And we could actually, with the 3 cells in series, we could actually power commercial electrical appliances like table fan, table lamp, all those things. So they gave us generous funding, and that project is still going on. The reason why they funded me was another reason, because they gave almost 15 crores to Nagpur University for a similar project. But unfortunately, they could not make an inroad into the proposed objectives. As I said, majorly because it's not their fault. It's majorly because that electrode combination is very, very important, and it is very specific, because urine is very corrosive. And most of the electrodes, the moment you put it, it will corrode. So you need to identify the right set of electrode combinations to make it work, and which my students did that after a series of their hard work. And that is why we were successful, and that is why they were funding us. And that is still going on. And this electrochemical stove, which I have shown, which we had done in a real scale with that urine battery concept. That is what it is at the moment.
Any other questions? We sincerely thank Dr. Muhammad Mustafa for the enlightening keynote session. Your scholarly insights and engaging presentation have deepened our understanding and inspired meaningful reflection. We are truly grateful for your valuable time and contribution to this conference, sir. Thank you so much. Now, I welcome Dr. Saumya, Assistant Professor, Department of Civil Engineering, to introduce our next session speaker, Dr. Raghunath, Retired Professor, Civil Engineering, BMS College, Bangalore. Welcome, ma'am.
Good morning to one and all present here. It's an honor and privilege to have Dr. S. Raghunath sir over here with us to represent Civil Department. I cannot say it is completely Civil Department, but when somebody is working on sustainable future, it touches almost all branches and domains, and for that reason we have sir with us here. I would like to be introducing sir to the gathering. Sir has done his B in Civil Engineering and ME Construction Technology from UBC, Bangalore, and PhD